All right, kiddos. So in our last video, we went over motion diagrams, specifically particle diagrams, motion in general, what a coordinate system was, vector, scalar quantities, and displacement. And on this video, we're going to focus on measurements. So a measurement is a quantity that has both a number and a unit. And I'm going to purposely highlight a couple terms here because they're very easy to forget. And that is the fact that there has to be a number as well as a unit. A number without a unit is absolute nonsense. So if I just wrote on a test, I have 23. What does that even mean? Do I have 23 computers? Do I have 23 goldfish? Do I own 23 dogs? Do I water 23 plants every day? The list is pretty much endless. You have to have a unit as well as that number in order for a measurement to make sense. So let's just say for some reason I have 23 pumpkins in my house. Now, you might think I'm totally crazy, but you'd also have an understanding that I currently have 23 pumpkins. It's a full idea, it's a full understanding, it is a full measurement. Now, that's hopefully easy to remember. If you are taking down data points and let's say you were timing your penny lab, right? Your time would be something like 0.64 and then you'd write an S for seconds, right? You have to make sure it is lowercase. You have to make sure it's almost a subscript. It's got to be smaller than the numbers. It can't look just like a 5. I know mine kind of does, but that's what you want. If you were measuring the distance that I had you cover in the penny drop lab, you should have written 2 and then an M for meters. And this whole video is just kind of break down what our normal units are, what the international system of units is, why we use SI units, and some of just, again, the basics of what they are and what they look like, shorthand and longhand. So for units, we use the International System of Units, which shorthand is the SI units. And this is pretty much just the metric system. So there are units we follow as scientists that aren't actually commonplace, especially in the United States. So in the United States, we easily measure things in miles or feet or inches or centimeters. But in the metric system, we really want to convert into meters and centimeters and kilometers. And so this is going to take us out of our comfort zone a little bit and force us into dealing with units we aren't used to. And so basically what the rest of the video is going to be is listing different types of units for different measurements like length or weight or whatever it might be. So here are 5 of the 7 basic metric system units. So for distance, we are going to measure in meters from now on. So meters, the shorthand for it is just, let's put a little equal sign. It's just a lowercase m. You cannot capitalize these lowercase letters, you cannot capitalize the shorthand of these units because it actually changes what the unit is. So lowercase m stands for meters. Uppercase M actually stands for molarity, which is something you will learn when you get to chemistry. So for mass, we tend to use pounds. We don't want to use pounds anymore. That's not something that is usable by every country. If you go into different countries and ask them how they weigh themselves, they'll say things like stones or kilograms, whatever it might be. So for scientific purposes, our SI unit for mass is kilogram. And that shorthand is going to be kg, again, all lowercase, kilogram. Now for time, pretty easy. We measure it in seconds, not in minutes, not in hours, not in days. It's always going to be in seconds. So sometimes you will have a measurement that comes up within days, or you've been studying something for, let's say, exactly 48 hours. You want to actually change that into seconds, whose shorthand is the lowercase s. And then for temperature, technically the SI unit is Kelvin, which is used because at 0 Kelvin, all life stops moving. Atoms don't have the ability to move. It's literally where life stands still. However, we tend not to use that as often, so what we'll use instead, I'm going to star this as like, yes, this is like our special one, but you will see that most use Celsius. So degrees Celsius is kind of where we're going to be at for our class. It is a little bit more common, and it actually shows up on our thermometer, so we'll use that instead. Normally we use Fahrenheit. Celsius is just, again, the way we stabilize it or normalize it, across all scientific areas of study. Now, for amount of substance, we're not going to use this one, but it's always good to get a little introduction into chemistry. So if you were looking at the amount of substance of something, in chemistry, you would use the mole. And I'm going to rewrite that because that was terrible. And the shorthand of which is just MOL. But that is how you find substance, or the amount of substance, is you find it within units of moles. These are the units I really want you to get comfortable with for the rest of the year. If I ask the distance of something, we should be responding with it in meters. If it's about mass, the mass should be in kilograms. If it is time, your answer should be in seconds. And for temperature, again, we go for Celsius. Now, if we have to do conversions between things, that I can kind of help you along with, but you want to make sure these are kind of your base units. We're going to use these SI units. The only other one I can think of that would come of help to you is if we ever talk about force. So our unit of force is going to be newtons, which, I'm going to make that a little bit nicer to read, which is just a capitalized N. Now, this, again, is one where it's very tricky doing the shorthand version. If you lowercase the n, if you write, let me pull over here, if you decide to say that something was pushed with 18N like that, you are wrong. That stands for moles of a substance in a problem, and so I will mark you wrong every time. We want to really make sure, I'm going to erase what I just wrote so it doesn't confuse you, that we are focusing on big capital M for newtons. And so those are kind of the base things to remember in this section. We've got an international system of units. We'll be practicing that, kind of getting used to it over time, because it is a big change for us living in America. We don't actually adhere to these most of the time. So it'll be a change. Just stay comfortable being uncomfortable for a while. You'll get it eventually. And the big one, that measurements are a quantity that has both a number and a unit. That unit is incredibly important, and dropping units is something we cannot do as scientists. So always remember that. And just as like a final thing, and I'll write this down and then stop the video, we use this SI units, these international system of units, so that scientists can understand each other's findings, whether they are a scientist in America or in the middle of nowhere Russia, right? We all have the same thing. If you are a scientist working in London or a scientist working again in Italy, you're all within the same units, so that it's very clear and easy to transmit or share scientific data and results.